Hello, so this is a basic setup video for Fluid Flow version 2.5. I've just imported a basic model from Mixamo, and I'll now show you how to set up Fluid Flow to work with this model. So the first step is to add a Fluid Flow canvas component. And in this canvas, we have to assign the renderers we want to be able to draw on. And in our case, this model consists of multiple sub-renderers for the different body parts. So in the Fluid Flow canvas, we can, for example, for now we will just do the body and the legs. And the Fluid Flow canvas internally has a single render texture, which will be shared by all of the renderers. So as the UV maps will probably overlap, we have to assign the each of the UV maps a separate section of the internal texture atlas. And theoretically, we could do this manually via these offset and scale properties. But it's a lot easier visually, so there's no this editor. And here we can see in the UV layouts of the both renderers. And these red marked areas are areas of overlap, and this is not good for painting to the model, as when this area here is painted, then parts of the face and parts of the trousers would be painted simultaneously. So we want to spread them out now. And theoretically, we could just select them and with the left mouse button, and then using the right mouse button, we can drag the UV layout to a section we want it to be. And with the Shift and Control keys, we can scale the layout. But there's also this utility AutoGrid layout function, which will try to lay out the renderers for us. And in this case, it's already worked pretty well. Currently in this texture is a 512 by 256, and we have the aspect ratio locked, and with this resize mode we just extend the canvas and we increase the resolution. Instead we could also disable this extend mode, and that will scale the contents also. And we would probably want something like 2048 by 1024. Should give us enough resolution for a clean look. And we see here that there are still a lot of spaces which are unused, and we could add other renderers in these spaces. But for now this should be fine. So the next step is here defining the texture channels. So each canvas can consist of multiple channels. For example, there's already set up the color channel. This is just for the base texture of the model. But we could also add a channel for the normal map. And these can be referenced indirectly or directly. For example, the normal map in this name here references a scriptable object. So we could also map this directly. And this is how the scriptable object is defined. So the scriptable object maps from the abstract name normal map to the actual texture properties on your shader. So for example, if this shader is not set, it applies to all shaders. So in this case, all shaders would apply this texture channel to the normal map, normal text property. And for the universal render pipeline lit shader, we want to use the bump map name instead, because there the normal map isn't called normal map, but bump map. And the same holds for the other channels defined here. So we have set this to target a normal texture channel, and we can also define the format to be, the format should also be a normal texture channel. This is also a scriptable object which defines which internal render texture formats should be used for this texture channel. And for a normal map, these here should be the possible channels, and this list just defines possible overloads, so it will on startup try the first one, and if it's available, it will use it, and otherwise the other formats will be checked if they are available. And yeah, you can define different texture channel formats for different use cases. For example, the fluid channel and color channel will have slightly different formats. So after we've defined the texture channels, when we started, we will see that there will be some problems. Yes, because we have the internal textures here are, as we've seen, they are shared by multiple renderers, but the materials of the model currently don't know how to unmap the texture coordinates back from this texture atlas to the actual texture coordinates. And for this, we can use this tiling and offset, which most materials already provide. And these tiling and offset properties can be set automatically by the fluid flow canvas. And that's what these overrides are for. And currently it targets the main text ST. This ST stands as the Unity default name for sampler scale transform, I think. But on this material we've assigned here, there's not the main text which has the scale offset, but it's the base map ST, I think. So this here is actually what defines the offset of the shader, the texture offset in this shader. So we want the base map with the ST postfix. So if we put it in here and ST, so we could also say that we want to target directly the lit shader, URP lit. But if we just leave this empty, it will apply to all, and as all of our materials are currently using the lit shader, it doesn't really matter. Let's just define the color format directly. There seems to be an issue still, and now it works. Okay, now when we want to paint to this texture channel, we can, for testing, add this simple project Decal component, which allows us to target a canvas and a camera. And here we can define a decal. For now it just has no mask and just draws a color directly. We can define a basic mask here and say we want to use the red channel of this texture as the mask. And now we can click on the model and paint on the main texture. Okay, so now when we want to use the fluid simulation, the first thing we need to add is the FFGravityMap component. This is component does the calculations for the gravity map, so it targets a canvas, and then for the renderers it generates a flow map with the gravity in UV space. And the default values here should be fine. You can add some random noise and it can be influenced by the normal map and stuff, but the default values should be fine for now. And now for the actual fluid simulation, we need a fluid flow simulator. And this is what actually handles the flowing of the texture. And here we have to reference the target gravity map. And then in there we have to target which texture channel should be simulated. And we can also, for now, just try the color texture channel. But we will see that this will not work properly. I've removed the simple decal projector. So if we re-add this quickly. We should see that the complete base texture of the model is just flowing away, which is obviously not what we wanted. And we didn't paint anything because I didn't activate the mask. So now, yeah, it does already look quite cool, but yeah, everything just flows away. And instead, to fix this, we'll need a separate texture channel which just contains the fluid. So we create a new texture channel and select fluid here. And as the format, we also should use a fluid format. The main difference here is that these are floating point render textures, so fluid can accumulate to over 1 unit, and so the range of the possible fluids is a lot higher. But the base shader, which is currently on here, the universal render pipeline lit shader, obviously doesn't support this new texture channel. So we will need a custom shader which allows to overlay fluid. And this is what I've already provided here. It's just a basic shader which supports overlaying this fluid texture. It's here. And if you also apply this to the trousers, and then we have to say that we want to simulate the fluid channel now. And inside of the Decal projection, we also now want to target the fluid channel. And instead of color, we want to define that we project fluid. And now we can set how much fluid we want to project. And if I have not forgotten anything, I have forgotten something. Now we want to target the fluid text sampler scale transform again, because this shader we've just selected, I can just open it up, uses the fluid texture scale transform here for unpacking the atlas transform. You can see that's actually pretty simple to create such a shader, and there are utility nodes included to make this as easy as possible. And with this, it should maybe work. Right. The fluid texture channel is currently, there is this last column, the initialization. For the color normal map, we just initialized it with what's already in the materials currently, so this texture of the model. But for the fluid texture channel, we want to initialize it to black, so no fluid. And now, yeah, you can see that the fluid behaves correctly and the underlying texture remains unaffected. And the look of this fluid can obviously be adjusted. For example, here the scale is a bit lowered compared to usual. And we can define how dark the areas with a lot of fluid should appear. And yeah, there are a lot of options for changing the appearance of the fluid. There's also some other effects we can add to this fluid simulation. So the fluid simulator handles the basic gravity calculation for the fluid, but there's also a fluid flow effects component, which also targets a gravity map. And here we can again define that we target a fluid channel. And so here the seam stitching will only be relevant for the particle-based fluid simulation, so we don't do this in this case. And now this can handle evaporation and blurring. So the fluid will fade over time, and the when a pixel has a lot of fluid and the pixels around it don't have as much fluid, then the fluid will spread to the surrounding pixels. And this will be more obvious with a more color texture. But you can already see, hopefully, yes, that the older fluid starts fading away. We can deactivate the animation for now to make it easier to see. So the fluids start fading, and then we can add new fluid, and so it layers on top of each other, and there's a more 3D effect to it. And to maybe show the blurring a bit better, we can disable the simulator. And instead of drawing a solid color, we can maybe use this checker here as the color we project. And now when we add a lot of fluid, you can see that the paint drops start growing and then start evaporating. And this growing is the blurring in action. And so if we activate the simulator again, now you cannot, no, we are not just drawing a solid color, but this checkerboard texture mask with the brush, the other texture. Okay, so that's basically it to the for the texture-based simulation. But since Fluid Flow version 2.5, there's also another option using the particle-based simulation. For this, we add the Fluid Flow Simulator Particle component. And similarly to the Fluid Flow Simulator, we just have to target a gravity map and target the fluid channel. And again, there are a lot of possible configuration options here to define how the particle should look, but the defaults should be fine for us now. The one thing is that we can't just project particles like we would a normal decal. So the particles have to be added to the simulator directly, and the decal projection projects the decals onto the canvas, and then the canvas gets simulated, the canvas texture gets simulated by the simulator. And if you want to add the particles to the simulator, there's this simple draw particle component, which also references the camera and then the simulator directly. And then the color of the particles, you can use some blood red. And if we start it now, yeah, you can see that we now paint these particle streaks. We'll just disable the animator for now. And this is the new particle-based fluid simulation. And you can also see that the effects are still active, so the fluid starts fading over time, and it's also blurring a bit. We can disable this for now. So if we disable the evaporation and blurring, these streaks should be a bit more defined and not just so blurry. And now we can also see that when we add the particle streams here, you can see the UV seam. And if we now enable the seam stitching option in the effects component, you can see that it reduces how visible the seam is. And if we also enable the fluid blurring, it will be even less obvious, and it basically just disappears. So UV seams will always be visible because the texel density will change and how the pixels interlock with each other. But the effect can be close to not noticeable. Okay, so one last thing I want to mention is that for the fluid simulation and gravity generation, the models need some pre-processing by the FluidFlow canvas, so the seams can be found and stitched together. And for very large models, this can be a bit expensive, so you might want to pre-compute these. FluidFlow version 2.5 now also has this generations 2 jobs with the burst compiler, so it's not too doesn't take too long, and this is also done asynchronously. So you probably won't notice a huge problem with it, but for very large models it might be useful to pre-cache this. And to do this, you select the model, and then you can create a FluidFlow model cache. And inside of this model cache, we can define what exactly we want to cache. And in our case, we want to pre-generate the data for the body and the trousers. And both use the first UV set. So we can just hit apply. And inside of the canvas, we can now apply this cache. And so the initialization of the canvas will now be faster, but it hasn't been a problem before. So we don't really see a big difference, but internally the initialization is now a bit faster. Okay, so that's basically it for the basic setup. If you have any further questions, just feel free to comment them or write me an email. So thanks for watching. I hope you enjoyed. Bye.